Let's look at how we could interpret a chromatogram. Now this one is made up data, totally made up data, but let's just say this is how it came out. How would we interpret it? Well, first of all, what is our unknown? Our unknown, because it has two spots, that tells us it contains two different substances. One of those we can tell by how it lines up. One of those is the lead cation. The other one is the copper cation. You see, on this one, the copper and the lead both moved according to their own properties. Even though they both started together down here, they were separated because each moved according to its own properties. So that's how you identify your unknown cations. We're also going to need to calculate an RF, a retention factor. Let's do one for lead. The thing we need to do is to know where 0 is. This line is like a start line. This line here is like a finish, at least for the solution. So we want to compare the distance that the lead moved to the solution. So RF equals the distance that the spot traveled divided by the distance that the solution traveled. So we need to know that this is 0. My ruler has a lot of spots in it and it's not quite lined up, but we'll say that's 0 and then we'll count up. Notice that 0 is not at the bottom of the page. 0 is from the line that you marked where you added all your solutions. And then we can estimate lead's position at the end. You want to estimate the center of this spot. This spot is about 1 centimeter wide, but we're estimating the center of it. Then come over here. Oh, that's not lined up real well. Let's try that again. So let's estimate that is 3.7 centimeters. And then for the solution, I don't want to measure the solution's distance just anywhere. For this RF, I need the distance that it went right here. And I would say that is about 6.5. Then I need 2 sig figs. Okay, so what about units though? If we look at our calculations, these centimeters cancel, so there are no units. No units, that's the correct way to write this. If it bugs you to leave it blank, you can write unitless to show you that you know that no, I didn't just accidentally leave off the units, they're not there. Sometimes they do that in books, so you know it's not an accident. But anyway, so no units on a retention factor. Also, another thing to know about a retention factor, that the RF is always less than 1. Why is that? If you look at how we calculate it, the top number is always going to be smaller than the bottom number because you can't have a spot that travels further than the solution up there. So this will always be a fraction. It will always be 0 point something. Another thing is that RFs are a physical property of a substance. And just like we said with the unknown travels according to its properties, not minding that it started off mixed with something here. Each substance travels with its own properties. So it doesn't even matter how long you let it elute. And let me show you an example. So if we run 2 chromatograms, and one we run really long time, and say our sample ends up in the very middle. So this would be an RF of about 0.5, wouldn't it? if we took the same unknown, same solution, same temperature, ran it less time, the unknown would still be about halfway up to where the solution is. The RF would be the same number. Okay. In this case, the distance that the solution traveled was less, but so was the distance that the cation traveled. So that ratio of spot over solution comes out the same.